Welcome, friends. You must be seeing that we are really very seriously warming up for taking a takeoff analysis. Reason is very simple. As I told you, there is to be a lot of accidents during takeoff and landing, and it's our prime goal to ensure that we understand everything about takeoff and landing and make sure that our honorable pilot is made fully aware of the real situation so that he can fly the airplane with full safe. And in talking about takeoff, I have requested our chief engineer to discuss with you about airspeed indicator, altimeter, little more than what we did in the first phase. Reason is simple. When a pilot is flying, please understand, for him, he is totally depending on airspeed indicator, altimeter, and few other gauges to infer whether he is in appropriate conditions for takeoff, landing, or cruise, or anything. So we have to be very, very sure you understand what is an airspeed indicator, what are the instruments, how do they measure, what are the sources of error. So for that I have requested him, and there is a module dedicated for that. And before we analyze this, we will see that you will have to go through that very clearly, and your mind should be very, very clear. Now, today at this point we are discussing about takeoff. Before takeoff, we revisit Vstall, and we have seen for 1G Vstall means when I define Vstall for cruise, we have seen this is 2W by S rho CL max. Please also understand, when you talk about Vstall, you should not think we are in stall. No. The correct interpretation of Vstall is this is the minimum speed with which you can fly an airplane. Any speed less than that, as far as air is concerned, this is not to be considered, right? I assume that's not available because that will not help in flying the machine. So there is a boundary. That is why Vstall is called the minimum speed, right? It doesn't mean you are in stall. Please understand that. Okay, let us see here. If I see Vstall, if I want to reduce Vstall, I want, yes, Vstall should be low. Why I want Vstall should be low? Because I know if Vstall is low, then the runway length for takeoff will be less. But how can I make Vstall low? One thing comes to my mind from here, that I should make W by S also low. That is true. That means the wing should have large area. Okay. Then only W by S will go down. Larger area wing has another problem. That is, it will have a lot of drag. Okay. So you won't be able to have a better performance in terms of high speed. That's why you'll find for a high speed airplane, W by S is not that low. It is the higher side. Okay. We will be discussing this in the 7th or 8th week when you will be cruising towards design. Okay? But at this point, keep this in mind. However, you should also notice here, this W by S is basically W takeoff by S. And suppose for some reason I want to take off at a shorter distance than being prescribed. So I myself, as a pilot, can locally change the wing loading. That is W takeoff by S. How? Suppose it is 10 passengers, I will not take 10 passengers, I will take 6 passengers. I will not take full tank of fuel, I will take less fuel. So total weight of the airplane will reduce. Of course, it will amount to range, not that what we otherwise get from the normal aircraft. But as far as takeoff is concerned, it is a routine practice that not all the time you are going full of full load, that is. And if generally when we are doing experiments here, sometimes we take full load, we have a capacity of 5 passengers, but depending upon wind conditions, we may be flying at a lower W by S wing loading by taking only 3 students. Okay? So that small correction of wing loading locally, the pilot has that option. Why I am saying pilot? Because remember, once the plane is given to the pilot, pilot is the pilot in command. He is the boss. Okay? So anything now you want to do, it has to be on the cognizance of the pilot. Okay? He has to say yes. Why I am talking about this Vstall, etc., you will appreciate. See here the density part, rho. Even for a same wing loading, if rho decreases, the Vstall increases. Vstall increases means you need larger takeoff length, because anyway V takeoff is some percentage more than the Vstall, because you want just lift to be just more than the weight. Okay. So as I am going higher and higher for takeoff, means let's say the airport in Delhi, airport in Leh Ladakh. So naturally that is a higher altitude. I am talking about takeoff, please understand. At a higher altitude, their density is less. Density is less means the Vstall at New Delhi will be lower than Vstall at any higher altitude, that is compared to Delhi, let's say Leh Ladakh, Kashmir. That is simply because this rho is less at high altitude. That means in Delhi, if it was taking 200 meters runway length, same airplane under same condition at Kashmir or at Leh Ladakh will take more than 100 meters. So sometimes it may happen. For a specific purpose, the pilot may reduce some load. That is, he may not take the full passenger, he may take less fuel and take off from that high altitude and come down to some other place. So these are the operational things based on this understanding. So what is to be understood is, even if wing loading is same, even if CL max is same, depending upon what altitude is your runway, the Vstall will change. So pilot will be aware of this. Okay? Fine. So once we are very clear about Vstall, we have also seen that I can reduce this Vstall by using flaps, right? Because by flaps, we are actually increasing CL max value locally. Okay? So by flaps, we are increasing CL max locally. Why I am saying locally? Because the moment I put the flap, yes, CL max has increased because camber has changed. But what is the problem? Problem is it has now contributed more towards drag. For example, induced drag, KCL square will increase, even CD naught will increase because geometry has changed. But for short duration, I will engine the aircraft in such a way that it takes that power, overcomes that sort of a extra drag. But that cannot be done for all. So, although flap is giving us more CL max, which we use locally for takeoff, but in actual flying, we are planning to fly at a condition where CL by CD is max. So you are not flying really with any flaps down, okay, for most of the flight, unless for some maneuver you may use, okay. But keep this back of mind, the flaps are primarily used for takeoff, and you will see flaps are primarily used for landing, not for cruise or any other place, right. So this is one so-called side effects of flap, that it generates drag. Also you will see, as I put the flaps down, the CL of the wing will increase. Suppose this is the wing. And here is the flap. If I put the flap down, now the CL will increase for same angle of attack. That is how CL max has been increased. So it will also cause some moment. So you have to also take care of that moment through elevator. Okay? So these are, in my language, I call side effects of flap, but they are really wonderful creation. It has saved us from reducing the requirement of airstrip length. That's very, very important for an aircraft. Now let us see, by regulation, what is the takeoff distance. Why I am using the word regulation? As you understand, this airplane, to be flown in a safe mode, the regulatory bodies have given some boundaries to ensure that even by mistake there are no accidents. Let me draw what is, as per regulation, the definition of takeoff distance. Say I start from here, v equal to 0, go to a point, or more precisely accelerate to a point where I have achieved v takeoff. I will explain you what is that v takeoff speed. Then I pull the nose wheel little up. We call it roll the airplane for approximately 3 seconds. Approximately 3 seconds. I roll the, and in actually in aeronautical language, I will not say roll. I'll say I'll rotate the airplane to an angle 1 or 2 degrees, but within 3 seconds of time. Then there is a transition, some sort of a curve, like a pull-up, and then climb. But climb up to a point when you have cleared 15 meters of height. And this is also called screen height. So what are the region you could see very carefully? One is SG, I'll call it ground distance. Well, what happens during ground distance? The airplane is here, after doing warm up, etc., etc. The pilot accelerates the airplane, attain a speed of V takeoff, then slightly rotate the airplane. So this time, now your nose wheel has left the ground, and still it moves like this. Then there's a transition, it's like a curved path, like a pull-up, and then doing this, he manages, controls the climb, and goes for a climb. Okay? So there are distinct regions. This I will call SR, that is rotational distance. This is, I will call it STR, that is transition distance. This is rotational. That is, during this time, the pilot has rotated the airplane and the nose wheel is no more touching the ground, but it's moving like this. And during this time, it is now taking a little pull up and trying to stabilize the airplane for a climb. So that is why I call a transition distance, STR. Okay, clear? So these are the 1, 2, 3, and 4. 4 segments. This is classically everywhere you will find. With new books you may find mostly they are talking about SG as takeoff distance, right? But we will talk what is by regulation and we follow that nomenclature, right? Typically, V takeoff is 1.2 times V stall, like 20% more than the V stall. Add that altitude where from you are flying, because the V stall will change based on the airport altitude, right? As I told, V stall will be different when you are taking off from Delhi compared to when you are taking off from Leh Ladakh. for the same airplane. Okay, that should be kept in your mind. So now what is our job? Our job is to find out this distance 1, 2, 3, 4. So I name it 1, I name it 2, I name it 3, I name it 4. But remember one thing, during the rotation, it's going like this, accelerated to V takeoff, then nose wheel up, still it is going with V takeoff. Okay? Here also, this is V takeoff speed. Okay? Well, let us try to find out the distance SG, SR, STR, and SCL. This will be SCL means distance during climb to clear the obstacle of 15 meter, which is also known as screen height. If this is understood, now I will also try to address one question here, that what is that CL max generally when it is going for rotation, how much he should rotate the airplane? Typically, I can tell you, that should be around 80% of the CL max. Okay? Should rotate the airplane, how much angle? Then you can take, okay, this will be around 0.8 of CL max. That is, that much angle which will bring 80% CL max for the airplane. And then he goes and takes off. Okay? But these are tentative numbers. Pilot will not see any gauge to see 0.8, 80% or 70%. That is the beauty of design. The design should make pilot so much adaptive that he should be flying. That's all. With 2 or 3 iterations, he understands. By feel, you have to give the feel to the pilot. That is why I am again and again telling that these instruments are important. Pilot gets the feel from these instruments and from the stick, through the stick force for a conventional airplane. And please also understand, with all these sophistications coming, where everything becoming electronic through display system, multifunctional display system, which by now you must be knowing that, the feel for the pilot has to be given very careful weightage. Because now autopilots are being used, actuators are used. So how a pilot will get the feel? That's also a biggest challenge, right? And there are ways of ensuring that still pilot develop the feel rather than seeing only the gauges. Okay? So we are not going to that now. We are assuming it's a simple plane where I can pull the stick, I can pull the rudder pedal, and from the forces, and I should be able to make out what is happening. Along with seeing those gauges, I know where I am and what should I do, how much should I go, how much should I climb, how much should I turn. All these things I get from the instruments, right? They are extremely important. So we now want to again come back to this estimation of ground distance. Let us go back to class 9, 10th. Even why 9th, 7th, 8 or 8, class 6, 7, 8. I remember, at least personally, there are 3 formula in physics became the lifeline. One was x equal to ut plus half at square, and there was v equal to u plus at, and third one was v square minus u square equal to 2as. Am I not correct? Whenever my teacher used to give me a problem in physics on mechanics, and especially on motion, rectilinear motion, I will read the problem and see what are the things given. If final velocity is given and distance is given, then I know I have to use this formula. If time somehow is given, then I know out of these two, either one or both of them has to be used. Whether both of them have to be used or not, that is to depend upon what is finally required. But almost I personally was doing this sort of a problem mechanically. Because my teacher told, don't worry about the acceleration, assume that the acceleration is constant. we are class 6th or 7th, there was no introduction to integration, differential, etc., etc. So most of the problem were assume that acceleration is constant. Then there were a series of problems where acceleration were not constant, very obvious from the description of the problem. The solution was, okay, take the average acceleration. It will work. Because those type of problem people have seen, if you take average acceleration, results will be okay. Now come back to this problem of estimating SG, and you will see how similar is the situation. Nothing has changed in last so many years as far as I am concerned. So let us first draw airplane. We know this is thrust, this is drag, this is lift, and here it is weight. Okay, and this is nose wheel on the ground, there are rear wheels or landing gears on the ground. Similar problem in class 6th, 7th, if I try to recall, it is there is a table, there is a box, or somebody is pulling it with tension T, and there is a friction coefficient of friction for the surface is mu, mass is m. Okay? Find the acceleration, find the distance in time t, or how much distance it has to travel to get a speed from 0 to say v1. All these problems were solved by either s equal to ut plus half a t square or v square minus u square equal to 2as, because the basic assumption was the acceleration is constant, right? If I try to compare these two problems, that is what I studied in class 6th or 7th, I do not see any difference. But for that, now I know the acceleration may not be constant. Why that is so? That also we should know. That is why we have made one video recording for you what a pilot will be doing for takeoff, how we will operate the engine, how we will go on increasing the thrust. All such things will be demonstrated, and you will see that. So this problem was easily solved because we assume that it is going on a constant acceleration. If I assume here the acceleration is constant, I am not doing anything new. Same problem I am solving. Okay? But let us see what actually happens for airplane. That is very important. If I now write or try to write equation of motion, before that if I try to write here, what will be here? T minus, there will be friction force, Ff, right? T minus Ff will be equal to m into A, F equal to ma. And I know because this mass is resting on this, so there will be a reaction R because of weight W. So I will write T equal to T minus mu R equal to ma, or T minus mu mg will be equal to ma. I will be solving this equation because R and W are equal. R minus W equal to 0, where there is the acceleration in the vertical direction. There is only acceleration in the horizontal direction. So this would have been the way to solve this problem, and A equal to then comes T minus mu mg by m, and you apply v square minus u square equal to 2as. So I find s equal to v square by 2a. If A is constant, my problem is solved. Okay? So this is very straightforward. If I try to solve this problem, assuming A is constant, which is for all practical purpose, it should be constant.